Hello, we are Taeyun Dayoung Lim, Chen-hee Lee, and Sang-yun Lee from Team 5. We will be presenting our software design description for our project. These are the contents for our presentation. We will first introduce our system, then we will present our system overview. Finally, we will finish with our system design. First, we will be introducing our system. The name of our system is Conbrio, which means a musical direction with spirit or vigor. As musicians, we need a case that can provide appropriate protection for our instruments. Traditional cases may be functionally great for this purpose, but they do not provide convenience as musicians need to provide continuous care for the instrument. To provide such convenience for musicians, we have come up with Conbrio, an innovative case system that provides useful functionalities for musicians. Now we will show the functional and non-functional requirements for our system overview. For the functional requirements, first, the case shall maintain the temperature and humidity set by the user. Second, the system shall record only the sound of the user accurately when the user performs in a music session. By attaching a small device with vibration sensor on their instruments, only the sound of that specific instrument is recorded, and users can review their performance efficiently. Third, for situations in which the user may have lost the case, Conbrio shall provide functionality for tracking the location. Users will be able to track the location of their cases with their smartphone application in real time. Next, the tuner in the case shall show the correct notes played by the user. And the metronome in the case shall play the beat according to the speed and meter set by the user. Lastly, the system shall send notifications through the smartphone application when charging the case is needed. Here's our non-functional requirements. First, the user manual shall provide appropriate guidance for the users. Second, the humidity and temperature error range shall be always kept. This range should be maintained to keep the ideal internal conditions of the case. Third, the GPS system shall maintain the desired accuracy to provide the correct location of the case. Fourth, the target reaction time and accuracy of the tuner and metronome shall be attained. The frequency should be kept within an appropriate range, and the tuner and metronome should show response within the target reaction time. Fifth, an appropriate security system shall be provided. And finally, the system shall appropriately handle system failure. Here's the full list of the functional and non-functional requirements in the system overview. You can refer to them by looking at our project document. These are the tasks for our system. To summarize them, the development environment should be built first. Then the embedded system, hardware system, mobile application, and add-on device should be built as the main classes of our system. Then corresponding subclasses like tuner system and speaker system should be built. Here is the full list of the functional and non-functional requirements in the system overview. You can also refer to them by looking at our project document.
This is the system architecture of Conbrio. Conbrio case consists of hardware and embedded systems. There are speaker, display, temperature sensor, and humidity sensor in the hardware. Embedded system consists of tuner, metronome, recording, security, battery, internal condition management, and GPS system. There is an add-on device that has vibration sensor. There is smartphone application for management and monitoring the system. We use GPS server as external system. This is the class diagram of Conbrio. These circled parts show us class diagram of embedded system and hardware. Embedded system has 7 subclasses. Each system has corresponding sensor as subclass, and they have their own attributes and operations. We can see that the embedded system sends signal to hardware, and this signal will be received by the speaker and display, which are subclasses of hardware class. Smartphone application class has relationships with recorded files as aggregation and with some embedded systems as dependency. It has 4 operations: set internal conditions, find location, find recorded files, and send notification. And add-on device class has relationships with recording system and tuner system as dependency, and has relationships with vibration sensor as composition. Add-on device has 2 operations: start recording and start tuning. Vibration sensor has an operation that filters frequency. Next, we will be introducing our user interface design. First, this is our smartphone application design. On the main page, you can see the current temperature and humidity of the Conbrio case with battery status. Also, you can find your case and look for recorded files by application. When you press current status, you can move to setting status page. You can set it as automated management mode or manually set the desired status of the case with recommended range. As you can see from the attached figure, users can get notification if the Conbrio case needs to be charged.
This is the mock-up design of the actual Conbrio case. In a closed state, the case shows temperature and humidity through an external display. NFC sensor reacts to smartphone to unlock the case and its applications. GPS sensor is also attached to track a location of it. This case is charged through a charger. In an open state, you can see two sensors which are temperature and humidity sensors. Also, the speaker and display for metronome are located inside of the case. There is tuner display too. Add-on device is a small device that has buttons related to sound recording. This is our use case diagram. There are actors like users, add-on device, and GPS server. The box in the middle indicates the main system of the Conbrio case. We modified the use case diagram from previous project since we modified actors. First use case is maintaining ideal temperature and humidity. It can always be useful since it is about maintaining the ideal temperature and humidity. Here, the actors would be the users and display. We have indicated the primary actor by coloring it as red. When this scenario goes successful, the internal temperature and humidity of the Conbrio case would be maintained in ideal condition for instrument. This is the sequence diagram for the use case 1. Since this use case is all-time working, the sequence is in the loop. The temperature and humidity sensor send the current status of the case to the management system. If the condition is out of the desired range, the management system controls the internal condition into an adequate range. Next case is recording only the sound of the users in the music session. It is hard for music players to recognize their own sound in the music session. So we provide the feature that users can record only the sound of their instrument. Successful end condition is that the users listen to their recorded sound and monitor their performance. The main actor is an add-on device that needs to be attached for the recording, and also the users participate as an actor. This is the sequence diagram for the use case 2. First, the user clicks the record button on the add-on device. Then, the add-on device transfers the vibration of the instrument to the recording system of the Conbrio case. Then, the recording system processes it into the audio file and sends the audio file to the smartphone application. Our third use case is finding out the exact location of the instrument case. This use case can happen when the users want to find where his or her instrument case is. Actors will be the GPS server and user. The successful end condition will be a smartphone application telling the user the exact location of the case. This is the sequence diagram for use case 3. The user will first request in the smartphone to find the location of the case. Then the application will send a signal to get location from the GPS, and the GPS will send a signal back and forth with the case. The GPS will calculate location and return the location to the smartphone. Lastly, the smartphone will display the location to the user.
Our fourth use case is about using a tuner. It is necessary for musicians when tuning their instruments. This use case successfully ends when the tuner system shows the exact notes that the user is playing. The primary actor is a user, and secondary actors are the add-on device and the display. This is the sequence diagram for our use case 4. The user's sound is the trigger for the overall process. The add-on device will then detect the vibration and transfer it to the tuner system. When the tuner system receives the vibration, it calculates the frequency and sends it to the display. Finally, the display simply visualizes its frequency to user. Our fifth use case is using a metronome. Metronome is one of the essential devices used by musicians. Conbrio case has its own metronome. This use case ends successfully if the metronome starts to play sound and displays the corresponding tick. Primary actor is the user, and secondary actors are the display and the speaker. And this is the sequence diagram. When user input comes in, the metronome system of the Conbrio case begins two parallel processes. First one is about the speaker. System will send the signal to the speaker, and then the speaker will start making a ticking sound. Second process is displaying metronome ticks through the display. Our sixth use case is sending notifications to users when charging of cases is needed. This one is useful when the battery of the Conbrio case is low. It automatically sends the notification to the user's smartphone application, which informs the users that the case needs to be charged. Successful end condition will be sending notification to smartphone application. And here the actor is the user. Our sequence diagram starts with iteratively conveying the state of the battery. While inside a loop, whenever the low battery condition is satisfied, the battery system will send a notification to the smartphone application. And finally, the application will show the notification to the user. And our last use case is about setting desired temperature and humidity. When the user wants to change the value of temperature and humidity inside the instrumental case, he or she can update the setting with the smartphone application. The successful end condition is when the internal conditions of the Conbrio case are set as desired by the user. Here, the primary actor is the user and the secondary actor is the display. The sequence diagram of our last use case is as follows. When the user changes the internal conditions with the smartphone application, it sends the updated values to ICMS, which means Internal Conditions Management System of the Conbrio case. And finally, ICMS operates to maintain the desired conditions. And this is the end of our slides, and thank you for listening to our presentation.